Let me first introduce myself, my talk guests or accompanies tonight. Yeah, you're my guest somehow. I can do what I want. I'm the first guy here. So I'm married to my wife Dina Wittfoth. She's also, like me, a new scientist. We're working in Hanover, Germany, and I'm also a Wim-Hof-Method instructor. Very recently became one. The same is with Matthias. He's here from this area, from Austria. He's also a Wim-Hof instructor. And what we're trying to talk about today is science, a little bit of science. And we try to show what has been already published, what we know about breathing and brain imaging, and what we are aiming at in the future. And we do this as an example with the Wim-Hof-Method. So it started for me with the Wim-Hof-Method. I heard a podcast interview with Wim Hof in the Tim Ferriss show 2 years ago, I think. And I find it fascinating. Started with the 10-week online course. And after that, I met Wim Hof. We were trying to set up some research together. And I have my own podcast since 1 year right now. It's called Inside Brains in Germany. And I interview guests from psychotherapy, coaching, and brain research there. And I was looking out for people who are familiar with breathing techniques. So I was looking for books, and I found the book from Wilfried Ehrmann, Handbook of Breathwork. Is there a translation, or is it just in German, right? Yeah. And I asked him for an interview, and we made one. And it has been downloaded since the publication nearly 10,000 times now. So people are very keen to know more about breathwork at all. So we will start with Matthias, who's introducing the Wim-Hof-Method. We'll tell you a little bit about the fundamentals of it. I will continue to present you some research that has been done with the method. And my wife Dina will end the talk to explain you what functional MRI is. Hopefully that is in a way that's comprehensible for you. We don't want to overwhelm you with scientific definitions and very complicated stuff. Well, it is complicated. We can't just get rid of it, but we'll try to explain you this matter in a very, hopefully, easy and understandable way. And she will explain what publication has been already done with breathwork and brain imaging. So I will give the mic to Matthias Berger, who will introduce the Wim-Hof-Method to you.
Thank you so far. So, my name is Matthias, as you heard. Just information for tomorrow, who is interested, maybe we have at 11:30 a.m. a workshop about the Wim-Hof-Method. We have a third instructor here, he's sitting here in front from the Netherlands. And if you want to know more, you can also ask tomorrow at 11:30. We make a nice dive in the creek there. It's 8 degrees Celsius now, so that's a little bit cold. So, about Wim Hof. Houston, we have a problem. There it is. This is Wim Hof. Maybe some of you guys know him. He's called the Iceman, yeah. Dutch guys are very nice, yeah. And he made a lot of crazy stuff. For example, I will translate some things from here. The longest ice bath, it was 1 hour and 52 minutes. So that's really long. Marathons in Finland, minus 20 degrees Celsius. He hiked the Mount Everest only in shorts. This is really crazy, but it is possible with the Wim-Hof-Method. So you're able to control your body. It's a lot of has a lot to do with mindset. And the interesting thing is, here it is, marathon in the desert of Namib without water. So the interesting thing is the Wim-Hof-Method is also helps to work to deal with hot environment, not only with cold. So let's have a short look at the 3 pillars of the Wim-Hof-Method. It's very short overview. So the questions afterwards, please.
Shoes? Did he have shoes? Or just
On the Mount Everest he had shoes, yeah. It's for the feet, it's very dangerous.
the others? No shoes. He had no shoes.
He had no.
Instead of Mount Everest.
Only on Mount Everest. Yeah, on the marathons he did it without shoes, but in the mountain environment it's very dangerous because of the grip. So it's very icy and it's not healthy then to slip away. Okay, we have 3 pillars of the Wim-Hof-Method. One is the cold therapy. How does it work? So we live in a very warm environment. We have heated houses, heated cars, and so if we are outside, we wear jackets. If you see goosebumps, oh my god, I have to wear a jacket, otherwise I have to get a cold. What we do is, we do the opposite. We go in the cold water to make training for the cardiovascular system. So we go in the cold to avoid getting a cold. That's important to know. It's also a little bit of, we play with sympathicus and parasympathicus, so with gas pedal and brake of the body. Very interesting to reduce the stress and have a better mind. Yeah? The breathing exercises, it's for sure for you here the most interesting part. What we do with the breathing exercises, we change the pH level in the body, and also the feeling of pain is less after the breathing exercises. We come also in a perfect state of commitment because the head is then empty after the breathing exercises, and that's the third part. To do this stuff in the environment, in the cold water, you have to be committed, you have to be focused. If you're not focused in the cold water, you can do it maybe 30 seconds, 1 minute, but not half an hour, or like Wim, 1 hour and 52 minutes. So that was very long, yes. It was a short overview, so in case you want to learn more, tomorrow 11:30 you will find us, and I give now the microphone to Matthias again. Matthias to Matthias. Thank you so much.
All right, okay. Now we're heading towards science a little bit. So there has been some publication done with Wim Hof himself and with his method. So he was getting to know some scientists, especially in the Netherlands, and they were trying to figure out what happens during the cold exercises, what happens during the breathing exercises, what effects they could measure them. And they tried to use methods and techniques from immunology that they are very experienced in. So they have a well-established method, and this is to inject endotoxins. These are dead bacteria into people that are evoking a very harsh flu response, flu symptoms, so headaches, and what you know about what you experience yourself when you get a flu. And these are injection. This is not dangerous for the body. So the body thinks in the first hours this is something dangerous. They are parts of the bacteria that's called LPS, lipopolysaccharides. Some researchers call them also little pieces of shit, because they are parts of the cell membrane of bacteria, and these are evoking the immunological responses. So they were injecting him and published a paper 2012 where they just investigate Wim Hof. So, and they found amazingly very interesting results, and they thought maybe this is very special man, yeah? It's not transferable to the overall human beings. So they tried to set up another experience that has been published 2 years later, where Wim Hof has trained a group of people with his method, and these groups were also injected with the endotoxins, and they were compared to another control group that haven't been trained with Wim Hof. So, and they tried to figure out what's going on in the blood and what parameters are very interesting. So Wim Hof has trained this group for, I think, just 6 days in Poland, very intensely, and they trained for themselves at home in the Netherlands for 4 days additionally, before they went into the medical experiment. And I will show you some parts of the publication to just highlight what's very interesting there. As you can see, these gray circles are depicting the breathing sessions. So at 0 they got the endotoxins, and they started 1 hour before the injection with the breathing. And the breathing session lasted for about 3 hours. So all the way during the coping with the injection, they did the breathing technique. And as you can see, the pH level with the trained group in the right corner goes up compared to the control group. They were more alkaline. And you can see the oxygen saturation in the blood was going down. I can show you another slide later. It's more detailed there. And you see also here in the lower left side that the symptom score, so what the people subjectively experience during these injections, so the symptoms of nausea or headaches, were much lower in the trained group. Some people hadn't any symptoms at all. Some people had very few symptoms compared to the control group. And here you can see one example from one person. So they investigated 12 people in the trained group and 12 people in the control group. And this is one example from a guy from the trained group. And you can see Wim-Hof breathing consists of 30 breaths deeply in and just letting go. Then holding your breath without air in your lungs for as long as you can do. Then breathing in, holding for 10 seconds, and then letting go, and this is 1 round. So you can see, this is called in this publication hyperventilation, the breathing round. So you can see hyperventilation here, respiratory rate, then the next column is retention, hyperventilation, retention, and so on. And you can see very interestingly that the O2, the oxygen saturation, lowers a little bit each round and goes to about 50%, which is very low. And we tried this also with monitoring the breath retention phases at our medical school. We had 50%, we had 40% people, and they were completely fine with this. So this is very, very interesting. And what is very astonishing also, they didn't look only at the blood gases, like the O2 saturation, CO2 saturation. They looked also at the hormones in the blood. So what you can see, and it seems to be that the Wim-Hof-Method is eliciting a kind of controlled stress response. So when the autonomic nervous system, and more specifically the parasympathetic nervous system, the stress system, the fight and flight response system, is activated, you have normally a kind of external trigger. Yeah, you seem to be in danger, or you seem to judge a situation as dangerous for you, so you get a stress response. And the breathing technique seems to evoke a stress response, which is corresponding to these hormones here, that is controlled, because the main a hormone for the sympathetic nervous system is norepinephrine or noradrenaline, which is the same. And this is not very different between the groups. It's just different on the last hours when the breathing session is already finished and terminated. So what's really interesting is that the adrenaline or epinephrine is much higher during the breathing, and it's even higher before they get the endotoxin. So before the 0 time point, 1 hour before, when they started to do the breathing, the adrenaline is very high. So, and the researchers concluded, based on these results, that the adrenaline, which is already known, is triggering immune responses in a good way. So if you have to fight and flight, you can't cope with any diseases at this moment, and with any things that might disturb you from fleeing or fighting. So adrenaline is emitted, and this is a good thing for coping with diseases and with your immune system. Dopamine seems to be not very different during the first hours, and cortisol also, the stress hormone, which is eliciting or which is emitted in the adrenal cortex, compared to adrenaline, which is emitted in the adrenal medulla, is not very different. It's just different in the last hours when it's faster down again. Do I have time? Hopefully, yes. The last slide from this publication is exactly with these cytokines. These are little proteins that are triggering and mirroring the immune response. And you can see here in the first A, B, C, D, E, F slides that compared to the control group, the specific immune responses, tumor necrosis factor alpha, interleukin 6 and 8, which are pro-inflammatory, so triggering your immune response, is much lower in the trained group. This is here the trained group compared to the control group, whereas the anti-inflammatory responses reflected in the interleukin 10 is much higher in the trained group. And this is, I think they wrote it like 200% higher than normal. So they can trigger their anti-inflammatory responses with this breathing technique. A thing which Wim is very proud of is that he has been already mentioned in one chapter in a biology book in the United States, Biology Now. And he is the method and the results are explained there. And what is also very amazing is that one of the high-ranking journals in science at all, like this one, Nature, has a little article about the publication about Wim Hof and the results that has been found there. So, I will give the mic to my wife Dina, and she will tell you more about what we can do with brain imaging and what functional MRI is. So, the stage is yours.
Hi everybody, thank you for the warm welcome. I think this is the first talk about science that I have ever done without shoes. So, yes, functional imaging. I'm very happy that you're all here and that you're not scared by this terminology. And there is really no reason to be, and I'm going to hopefully give you a little food for thought and some things to put into your pockets to explain to your clients and other people who might be asking you about these things. So functional imaging, what is this? We have a big magnet. It's the MR machine where we put our subjects in and we measure their heads. And then we get some pictures. And you probably have seen something like this, right? Where you get these little colorful blobs on an image of a brain. So there are two different things that we measure. Some of you might have been in an MRI machine because they had some issue with their back or some nerve issue or whatever. And this is usually an MRI, which is done for brain anatomy or anatomy in general. So what we do essentially is we have a very high resolution image of the brain. It's like a photograph, just the status quo. One image where you can look at pathology, maybe is there a stroke, is there a herniation of a disc, something like that. But what we're doing is we're looking at brain functions. So we're looking at the brain working. It's like a video of the brain. So it's not one static image, it's several images over a time course. That's one important distinction. And I'm going to show you, I hope this works, I'm going to show you 2 videos of the kind of data that we get out of the MRI machine, and the person who spots the colorful blobs will get a reward. So I hope you can see that there is something moving here. Now there is breathing, and now there is no breathing. This is the retention phase. And were you able to see the differences? Yes? Yes. And I have another video where it's even clearer. It's the power breathing. This is you inhale, exhale very fast, and then you inhale and press. So you have a breath retention with pressure, with air in your lungs. This is a little more forceful. And it starts now, you can see really a lot of, it's like disco lights. And now it's gone. This is the retention phase. So has anybody spotted these? No. Sorry, no prize for you. But what are these colorful blobs that we see? It's not in the raw data, so what is it? It is, in essence, a graphical display of statistical comparisons. So we do have to do some calculations afterwards, and what you see here is just statistics in colors. This is all there is to these blobs. So it's not something that is in the brain, really. It's something that we, in the post-production, so to say, map onto the brain, but it's statistics. Okay, but what do we measure in functional imaging? And what we measure in functional magnetic resonance imaging, which is long for fMRI, is we measure the vascular response during brain activation. So we don't measure neural activity. This is also another important thing that you have to keep in mind. We measure changes in blood flow that we know are somehow connected to neural activity. So imagine you have a neuron that is active, and in order to be active, it needs metabolism, it needs oxygen. So there is a difference in oxygen utilization depending on whether a given neuronal population is activated or not. That's one thing that constitutes the bold contrast. The other thing is blood flow, and the blood flow can be influenced by, for example, hypoxia, hypercapnia, other things. And the third part that is important for functional imaging is blood volume. And blood volume is influenced by vasodilatation, so autoregulation of the vascular response. So actually what we're measuring is changes in blood flow and blood oxygenation. More activity, more oxygen consumption, more blood flow to the region. And the good thing about this is that the magnetic properties change when oxygen is consumed, and we can measure this contrast. And this contrast gives us the statistics we need to create these colorful blobs. Okay, so it's a little through the back door, actually, what we're measuring. The bold contrasts, just so this is the take-home message, has something to do with oxygen consumption, which has something to do with neural activity. Okay, so you're breath workers. You know that breathing has profound effects on your physiology right away while you're doing it. And the good effects that you would like to measure in the brain are actually really hard to measure, because imagine you're doing this, you're breathing really a lot of oxygen in, you're exhaling a lot, so the O2, CO2 levels change quite a bit. And you were able to see that actually with the little movies. You saw that there was a lot going on in the whole brain. And this global effect that you see during the breathing makes it really hard for us to get these blobs, because then they are very unspecific, right? Because what we would like to have is something like this, small regions that are responsible for controlling your breath or whatever you're doing. But actually what's happening is that the whole brain lights up like a Christmas tree, okay? So this is probably one reason why breathwork has not been very prominent in neuroimaging, is because it's technically really hard to do. But there have been some people trying it, especially in animal models, which is not something I think is a good thing, but some of the things we know are taken from animal research. These are studies in humans, and this one is actually a CO2 challenge. So people didn't do anything specific with their breath, but they were, through a mouthpiece, they received air that was changed compared to the air you normally breathe. It had a different CO2 level. And then the body, of course, notices that, even if you're not consciously aware of it, and tries to counter-regulate this effect. And we only found, well, actually 2 days ago I found another one, but this was the one study that we found that actually did something you might consider in the direction of breath work. They told their subjects to hold their breath for 15 seconds. So you breathe normally, and after the exhalation, you hold your breath for 15 seconds. And then we don't have this Christmas tree problem, right? Because you're holding your breath. And I don't want to bore you with the gory details of the brain regions. I just want to show you that they do get some results. And they did some correction for this O2, CO2 problem that I've been explaining. But it's very hard to tell whether these are real activations or whether they are more related to the overall change of oxygenation in the brain. This is only one study, and usually you need replications and replications and replications of something like this to be confident that this is a true effect, which is why I will not give you a breath holding is in that area take-home message, because it's just not there yet. So these are in cortical and subcortical areas. So that's the cortical areas are the ones that have something to do with conscious, controlled, effortful activity, and subcortical areas are more related to emotional, more automatic responses. And then if we go one level below to the brainstem, they also looked at the brainstem, and I will just leave you with the images. So they did something there, but bear in mind, this area, this is the brainstem, it's down here. It's part of the brain, and it goes into your throat a little bit, right? And what goes through your throat are all the large vessels going to the brain. And what do? They pulse. What does every neuroimager hate? Movement. Because movement, especially if it's correlated with your task, will make it really hard to see if there is anything there. So I don't really trust these results, right? Because these are from 2008 and 2009, and there was just the methodology was even less well adapted to what we need. So they did find something there, but it might as well just be pulsation from the big vessels. We don't know. This is taken from animal research, but this is something that you can really take home. This is the brainstem, only the brainstem respiratory network. And you can see that there are a lot of nuclei. It's very complex. Something so simple as breathing is so complex in the brain. And might give you a clue why breathwork has so many effects. Like, put a cortex on top of that, of a higher mammal, like human, and multiply that by, I don't know, I don't want to give you a number, 1,000, and it gets even more complex. So the effects that we're looking at are unspecific in the sense that they are very much diverted in a network. And there are several routes to go to try and tackle this topic. And neuroimaging is one very interesting but also very complex part to do this. Nevertheless, we're scientists, we're nosy, and we would like to do things that, or measure things that nobody has measured before. Star Trek. Yes, I watched it. So we are setting out to do some research with the Wim-Hof-Method, and the good thing about this is it's very specific. You have a very specific breathing method that you can measure. There has already been stuff published on this, so we have some knowledge about where to look, like what might be a good idea to look at. And so we're going to have 2 branches, and this is work in progress. We're just setting this up. We're going to put people into the scanner. We're going to look at O2, CO2 saturation, and because we need that to correct our imaging data. And one very new development that is going to be very helpful for us is that we have a colleague in Hanover who is a brainstem expert, and he has developed a toolbox that makes it possible to mask the brainstem and to filter out all this pulsation and everything and make all the nuclei visible. Also, the measuring sequences that we use now are very high resolution. So they used to be 3 by 3 by 3 millimeters, and now we can go down to 0.7 millimeters squares. So that's a lot more fine-grained than it used to be. And I'm very keen to see what we get from these methods, because this has never been done before. The other branch will be HRV analysis and some blood work and blood gas analysis. And for both branches, we're going to do functional medicine, which is essentially looking at the microbiome, looking at inflammatory responses and the like. And this is also a very new development, and I think there are going to be very interesting results in this, just from breathing. I mean, I don't have to tell you, but... Okay, so as Matthias has already said, there will be a workshop tomorrow at 11:30.
I heard about 11:30.
11:30?
Yeah.
Okay, so 11:30. And you can try, because the guys from the Netherlands who did the PNAS study with the group are now setting out to investigate the cold immersion, the effects of the cold immersion, which is one of the important pillars of the Wim-Hof-Method. And I believe that this is also very important, especially for the effects on the immune system that we see. So they really go hand in hand, and if you're interested, try it. It's really amazing, doing the breath work and then going into the cold water. I mean, some of you have some experience with this, but it's really amazing. And I'm not sure if the next slide is correct. Time for questions? Do I have time? Do we have time for questions?
Yes.
Yes, okay. So I hope I didn't confuse you too much, and I hope that you got some food for thought and some things to put into your pocket and know what these blobs mean and how to interpret them. And when people come with, well, look, there's a study here, then you can say, well, be a little careful, we don't know that much yet. We know it works for us, but science has to catch up and give us some time, and we're at it, and we will hopefully at one of the next GEEKs be able to present the results.